Hello friends! So today we're gonna do multiplication of matrices, and before that let's check our work together from our previous lesson, okay? Alright, so this is our previous homework, okay, exercise 6.1, number 1, 580. Okay, let's check the answer together first. Okay, this answer is from Marco from year 11B. Okay, let's check the answer for exercise 6.1. Okay, this is exercise 6.1, number 1A. The answer you need to state the order, right? So the order is 3 by 2, or if you write 3 with the times, right, 2, also acceptable. Okay, this means 3 by 2, by the way. So 1 by 4 for B, for C, D, E, and F. Please tick your answer, and if it's wrong, please use red pen to correct it. All right. Okay, and then look at number 5AD. Number 5A, you need to look for the unknowns. Okay, the value of the unknowns here, x is 7, negative 5, and k is negative 2. K is negative 2 because negative 3k equals to 6. Okay, when negative 3k equals to 6, your k is 6 divided by negative 3, which is negative 2. Okay, and then D, okay, for your x, y, n, and k, okay, it's only comparison, by the way, to find the answer. Okay, let's look at 6.2. 6.2 is just addition and subtraction. Okay, all the 4 answers here is correct. This is C and this is E. Yeah? Okay, so for addition and subtraction, you can just plus and minus on the same row, same column. Okay, so let's look at the multiplication of matrices. Okay, multiplication is a little bit complicated compared to addition and subtraction. Addition and subtraction are much easier because you plus and minus according to the order, according to the row and the column. Okay, but multiplication is very different. Okay, but before we do the multiplication of matrices, let's look at the example here. Please copy down the notes here, the example. Okay, so look at the example here. From here you can see there are two matrices. Okay, the first matrix is this matrix and the other matrix is this over here. Okay, it looks like a table without the lines. Okay, it's actually look like a table but without the lines. Okay, can you look at this first? Okay, the first matrix here, right? Okay, this order, let's talk about order first, right? The order for this matrix, right, it is 2 by 3. Okay, 2 rows and 3 columns. Okay, and this matrix over here is 3 rows. Okay, row, we look at the horizontal first. 1, 2, 3, 3 row by 2 column. So this is 3 by 2 column. Okay, so what do you understand about the first matrix? Okay, I've labeled it already. We have bakery A for this row, and we have bakery B, okay, the shop B for second row here. Okay, this is row 1, this is row 2, right? And this first column is donut, chocolate bun, second column, and your third column is for croissant. Okay, so okay, in this word problem, okay, let's say I'm giving example, this bakery A, right? Okay, this bakery A sold a total of 5 donuts, 4 chocolate bun, and 1 croissant on that day. Okay, and this bakery B sold 7 donuts, 3 choco buns, and 2 croissants on the same day as well. Okay, this is how you look like. It looks like a table, right? But it's just that it is written in matrix form. Okay, and this matrix here, okay, what I label here, it means that this is the price of the donut, which is $1 each for one. Okay, and this price for choco bun is $2 each, and the croissant is a price of $3 for one. Okay, and this column here is for mass. Okay, for one donut is 80 gram, for choco bun is 100 gram, and for croissant is 50 gram. Okay, this is for each. Okay, this is just an example for me to write down in a word problem. Okay, because when I multiply, I will let you see how multiplication of matrices actually work here. All right. Okay, so let's say, okay, you already understand this column and rows here, right? Okay, it looks like a table but just without the lines. Okay, what you need to understand is the row and the column only. Okay, so now if I were to look for total price of the 3 items, right? The 3 items here, referring to donut, choco bun, and croissant. Okay, these 3 items sold by bakery A. Okay, if you want to find the total price, right, we know that this bakery A sold a total of 5 donuts. Okay, and 1 donut price is $1. Okay, and the choco bun, this bakery A sold a total of 4 choco bun with the price of $2 each, and the croissant is $3 each, and this bakery A sold a total of 6 croissants altogether, right? If you want to find the price, right, the total price, how are we going to do? If we do it manually, how would we do? If the total price that this bakery A received is the 5 donuts times with the $1, right? For each, 5 times the 1. Okay, I'll write it down. So 5 times 1 plus with 4 times 2. This 4 represented by the chocolate bun for 4 and the $2 price, and 6 croissants times this $3 each. Okay, can you see that? This is the price, total price for donuts, total price for choco bun, and total price for the croissants. Okay, so it times this way. 5 we times with the 1, plus 4 times with the 2, and plus 6 times with the 3. Alright? Okay, so here we total up and we get, I write down first, $5 plus $8 plus $18, which sum up to $31. Okay, so the total price of the 3 items sold by bakery A is $31 lah. Okay, in this case you times this way, right? The row and this column here, row and the first row and the first column. Alright, let's look at question 2. You need to find the total price of the 3 items sold by bakery B. Okay, so now let's look at bakery B. Bakery B sold a total of 7 donuts, 3 choco buns, and 2 croissants with $1 donut, $2 choco bun, and $3 croissant for each. Okay, so if the price for each is this, right? So we have to times and sum it up to find the total price, right? So here, $7 plus 1 as $7 plus 7 donuts times with $1 plus with 3 choco bun times 2 plus 2 croissant times $3. So the total here is 7 plus 6 plus 6, which is $19. Okay, so total price of the 3 items sold by bakery B is $19. Okay, on that day, this bakery B sold a total of $19. Okay, so how about total mass of the 3 items sold by bakery A? Okay, so again, bakery A sold a donut of 5 donuts, 4 choco bun, and 6 croissants, and the mass for each donut, choco bun, and croissant in gram is respectively 80, 100, and 50. Okay, so if we want to find the total, we times with the donut and the one of the donut mass, and choco bun also, and croissant also, right? Okay, so same thing here. What we do is we times the first row with the second column here. Okay, 5 times 80 gram plus 4 times 100 gram plus 6 times 50 gram. So total up, okay, it's 400. Okay, so it's 1,100 gram. Okay, this is for bakery A. So remember this one, the first column, first row times with the second column. Okay, and let's look at the total mass of the 3 items sold by the bakery B. Same thing, bakery B. Okay, your second row times with your second column now, because second row is on your bakery B. Okay, so 7 times 80 plus 3 times 100 plus 2 times 50. So it's 960 gram. Okay, so you can see if I want to answer one by one like this, right? okay, one by one like this. This one, price of bakery A, total price of bakery B, total mass of bakery A, total mass of bakery B. Okay, what if we use a multiplication of matrices, okay, in this form, whereby we use matrix of this times with the matrix of this. Okay, so when we times this, right, okay, actually what we get is like this. When we multiply this one, what we get is this one. Okay, what is this represented as? Okay, this one is the total price. Okay, and this one is the total mass. Okay, and this is for bakery A, and this is for bakery B. Okay, can you see that? The $31 is the total price of received or sold by bakery A, and bakery B is $19 for the total price, and total mass is 1,100 for bakery A, and bakery B is 960 gram. Okay, so this is how you actually times, right? Okay, this one I show you as an understanding. This whole question is for you to understand it only. Okay, understand as in when I say how do you actually find a total price, you can logically think that it's actually times this way, right? Like the donut times each price of the donut. Okay, this is logically thinking how to do. But in terms of metrics, when you have two matrices like that without any without any example, a proper example, for example, how many donuts here, how many price here, you don't have a proper like that, right? So when you multiply, there's a technique on doing that. Okay, the technique is it's almost the same as this. It's actually the same lah, basically. It's just that without the word problem. Okay, this one is with the word problem because I wrote the donut lah, chocolate bun, croissant, bakery A, and all that, right? Okay, so we move on to the next try it. Okay, next example, which I won't show you any word problem, okay, but I'm teaching you the technique on how to multiply. Okay, right, we will go back to this later. Okay, we'll go back to this later, but before that you need to know about this before you start multiplying matrices. Okay, if we have matrix A and if we have matrix B, when we times and if it's equals to matrix C, we must first look at the order. Okay, the most important step is look at the order. Okay, order is important. Okay, look at the order. Okay, if this order A, right, order means the row times column, row times column. Okay, if the row times column or row by column for matrix A is, let's say, m times n. Okay, matrix B, it must follow this column. Okay, this is row times column m times n, right? And for matrix B, the column here must be the same as the row for B. Okay, for example, n times or by order n by p. Not necessarily have to be same as the m here, but this one, these two must be the same. Means that this is the row and column for AB and BC. The column for the n and the row for the B must be the same. Then only can multiply. If not same, then cannot. Okay, this one must be equal. Okay, if not same, what happen if not same? If it's not same, okay, or if it's not equal, then there is no solution. Okay, then it's undefined. You cannot multiply a matrix that the column and the row for these two matrices are different. If they're different, it's undefined. You cannot multiply at all. Okay, and if your matrix C is a product of matrix A times matrix B. Okay, and the product for this, the order for this matrix C, is actually from here, which is your row and column here. Okay, this M, okay, and this P, Okay, the row and the column for this is your matrix C. Okay, so your product, okay, or your answers for your C, the order is M times P. So it depends on the row and column here as well. Okay, please note this down. Okay, you must make sure that the column here and the row here is the same. Okay, let's go to example straight away, alright? Shall we? Okay, we go back to this first. Okay, you look at the order. The order for this is 2 by 3. The order for this matrix is 3 by 2. And you look at the column here and the row here, they are the same, right? So if they are the same, yes, you can multiply. Okay, and your final product will be 2 by 2. Look at this 2 by 2. This product is 2 by 2, right? That's why it's coming from here, 2 by 2. Okay, from the row of this matrix and the column for this matrix. Okay, remember this is the row, this is the column. So the product, the answers here, depend on the row from here and the column from here. Alright? Okay. So let's go to try 6. Okay. First, we need to find out the order first. Okay, we need to find out the order. Okay, let's look at matrix here, matrices. There are 3 matrices here. Matrix P, matrix Q, and matrix R. So first step is you have to look at the order. Okay, the order for matrix P is 2 row by 3 column. Okay, so 2 by 3. And for Q is 3 by 2. And this R here is 2 by 1. Okay, so find the following products. Products means after you multiply, where possible. Okay, we have to see whether it's possible or not. As I mentioned earlier, right? It is not possible if, okay, if, again, the column and the row here are different. Okay, if they are not equal, okay, or if they are different, it's not possible to multiply. Alright, let's look at this if it's it can be multiplied or not. Alright, so P times Q. Okay, matrix P, matrix Q, when you times, okay, I'm doing part A. Okay, matrix P is 2 by 3. And then matrix Q is 3 by 2. Okay, matrix P, matrix Q. These two are the same. Okay, so you can multiply. And your final product, right, it must be 2 by 2. Okay, 2 row, 2 column. Okay, this will be your final product. Okay, so how do we multiply, right? Okay, now I'm teaching you the technique. PQ. You have 1, negative 2. Okay, I copy all this down. Please copy all the questions together with the answer. Okay, so to multiply, right? Okay, as I say, you focus on row and column. Your product comes from P and Q, the row for the P and your column for your Q. Okay, row for your P, there are 2 rows. Okay, I'll write down here. This is row 1, this is row 2. Okay, and your column here, right? You have column 1 and column 2. Okay, this row 1, right? This row 1 is referring to the P. Okay, row 1 and row 2. And the column 1, column 2 is referring to the Q. Okay? Okay, so you must focus on the row and the column. Okay, your final product is 2 by 2. How is 2 by 2 looks like? Okay, 2 by 2 will be like that. You have 1 here, 1 here, 1 here, and 1 here. That's why you have 2 by 2. Correct? Okay, so this one is your first row, first column. Okay, this element here is your first row, first column. This element here is your first row, second column. Okay, first row, second column. Okay, here is your second row, first column. And here is your second row, second column. Okay, please don't get confused. Okay, remember it's your row 1, row 2, row column 1, column 2. Okay, if you don't want to write like this, you can always write this way also can. Okay, row 1, row 2, column 1, column 2. Okay, so you have 4 answers here. Okay, I'm not gonna underline that. Okay, so your first answer here, right, it must be coming from your row 1 and column 1. Okay, row 1 and column 1. So if row 1 and column 1, we focus on this row. Okay, maybe I can use highlight. First row, okay, first row and first column. Okay, this is first row, first column, right? So first row and first column. So first row and first column, what you need to do is you have to multiply and plus, just like how you do from the beginning of the lesson, the example there. Okay, 1 you times with the 6, plus 3 times with negative 1, times with 7 times, plus with 7 times negative 9. Okay, I think I'm not enough space. Okay, this is your first row, first column. Okay, so it must be coming from your first row and first column here. Okay, and here will be your second row, first column. So you must take your answer from second row and first column. Okay, see overlapping here. So first row, second row, first column, negative 2 times with the 6, plus with 5 times negative 1, plus with negative 4 times negative 9. Like that. Okay, so you look at the highlight color. Okay, so to get this answer, this is row 1, column 2. Okay, this element here, okay, will be from row 1 and column 2. Okay, so always comes from the row first, row 1 and column 2. So your first row will be this, and column 2, the green one. Okay, so it will be 1 times with a 0, which is 0, plus with 3 times 8, plus with 7 times 2. Okay, like that. And your second row, second column is here. Second row, second column here. It will be from here and this. Okay, second row and second column. So negative 2 times 0 plus 5 times 8 plus negative 4 times 2. Okay, you see, this one times with this, plus this one times this, plus this one times this. This is what you get. Okay, and then what we do is we simplify them. I know it's a bit complicated, but make sure you try to grasp it. Okay, it's difficult at the beginning, but once you learn it, right, you know how to do it already, right? It's easier already. You just focus on the row and the column. Alright, so this one, okay, let's finalize the answer over here. 6 minus 3 minus 63. Okay, I will write down the working. Negative 12 minus 5 plus 36. 0, I don't need to write. 24 plus 14 minus 8. Okay. And my answer will be negative 60, 19, 38, and 32. Okay, so that's my answer for matrix P times matrix Q. Okay. Alright, let's go to B. So now let's look at B. B is Q times P, right? Okay, so let's look at Q. Your Q is 3 by 2. You must first, for multiplication, you must always look for the order first, right? Because we need to know what is the product also. What is the order for your product? Okay, so Q is 3 by 2. Your R is 2 by 1. Okay, and these two same, equal, so you can multiply. I take means I can multiply. So your product, your answer will be 3 by 1. Okay, this is row, this is column, right? This is row by column, by the way. So we are taking row from matrix Q, multiply with the column from matrix R. Okay, how do we do that? Let's copy down the question first. 6, negative 1, negative 9. Multiply with R, which is 5, 1, like that. Okay. So I list down the row first. This is row 1, row 2, row 3. Referring to this matrix are row 1, row 2, row 3. This is column 1, only one column. Okay, so row by column. Row by column, row by column. And your product is 3 by 1. Okay, this is your Q, this is your R. And your final answer must be 3 by 1. 3 by 1 means like this. You have 3 answers like this, 3 by 1, okay, which consists of 3 rows and 1 column. Okay, for the first time you might need to write down the row and column like this, but after you have familiarized with the multiplication, you don't even need to write this row and column anymore. You can just multiply like that, like, oh, straight away the first one is 6 times 5 plus 0 times 1. You can straight away multiply without writing this down. But in the beginning, if you are first time doing matrices, okay, if this is convenient to you, you write it down. Okay, so this one, this is first row, first column, right? Okay, if this is first row, first column, then it means that you have to times, okay, first row, this one, with your first column. Okay, the pink one, first row, first column. So this is 6 times 5 plus 0 times 1. Basically, you don't need to write the 0 times 1, 0. Okay, and then you look at your second row, second column. This is second row, first column. I mean second row, first column. Second row and first column. Yeah. Okay, so negative 1 times 5 plus 8 times 1. Okay, this is your second row times with the first column. Okay, and the third one is here is row 3 and column 1. So row 3 and column 1. So row 3 is negative 9 times 5 plus 2 times 1. Like that. Okay, and then multiply. This is QR, right? Oh, this is part C, sorry. Later I'll do part B. This is part C, sorry. Okay, this is part C. Later I'll be doing QP because I see wrong. I thought it's QR. I thought part B is QR. Actually, it's part C. Later we do part B. Okay, so this one will be 30. And then this one is negative 5 plus 8. Negative 45 plus 2. So your final product or your final answer will be 30, 3, and negative 43. Okay, that's for QR. Okay, let's go back to the B. I missed out the B. B is Q times P. Okay. Now, if we have Q, matrix Q times with matrix P, matrix Q here, the order, okay, always look for the order first, is 3 by 2. Okay, matrix P is 2 by 3. Okay, see if they can you can multiply it or not. Okay, these two same, equal, means we can multiply. Now we look at this one and this one. This will be the final product, okay, which is 3 row and 3 column, 3 by 3. It will be 3 by 3. Oh, 3 by 3 is quite big. Oh, okay. Okay, Q will be, write down the question first, times with P. Okay, nah, like that. Q multiply with P, okay? Okay, let's say if I'm not writing down the row and column, okay, how do I do it? Okay, I know my final answer is 3 row, 3 column, 3 row and 3 column. Okay, if you want, you can do like that. Okay, 3 row, 3 column, like that. The first one here, we know this is first row and first column. Okay, first row, first column. So first row, first column comes from this one and this one. Okay, first row, first column. Okay, so it will be 6 times 1 plus 0 times negative 2. Alright, like that. And for here is first row with second column. Okay, so this is my first row. My second column now is this. Okay, first row with second column here. So it will be 6 times 3 plus 0 times 5. Okay. Okay, and the third one here will be first row and third column. Okay, I change it to third column like this now. So it will be 6 times with the 7 plus with 0 times negative 4. Okay, like not clear. Alright. Okay, so that's for my row 1. This is my row 1. Okay, now let's do row 2. Your second row. This is second row. Okay, let's focus on the second row. Your second row is here. Second row with first column is here. Second row, first column, second row, second column, second row, third column. Okay, second row, first column, negative 1 times 1 plus 8 times negative 2. Okay, and here is my second row, second column. I switch this one to here in the next column. So negative 1 times 3 plus 8 times 5. Okay, and then here will be my second row and third column. Here. So it's negative 1 times 7 plus 8 times negative 4. If you understand already, you don't need to look at my working. Okay, so now let's focus on the third row. This is your third row, by the way, right? Third row, and this is your first column. So this one with this one first. Negative 9 times 1 plus 2 times negative 2. Okay, always times and plus. Times and then plus this. Okay, here is your second column. So switch this over here. So it's negative 9 times 3 plus 2 times 5. Okay, and the third one over here, the last one, will be your third row and your third column. So negative 9 times 7 plus 2 times negative 4. Okay, so this one, remember, if you have written down this, right, okay, you erase it back. Okay, we don't need that. If you insist you want that, you put dotted line. Supposed to have more space, this one, you give a little bit more space here. Don't be like mine, have a bit more space. So 3 by 3, you have 9 elements here. So this one, after I count, I get 6. And then the second one is 18, and then this one is 42. Count, mana tahu I got careless mistake. It's negative 17, 37. This is negative 39. Then negative 13. This is negative 17. And this is negative 71. Okay, that's the final answer. 3 by 3. So this is QP. Okay, so we have done A, B, and C. Okay, now let's look at D. Okay, D, no space, I put here, D. So R times Q, matrix R times matrix Q. Okay, matrix R is 2 by 1, and your matrix Q is 3 by 2. Okay, these two not same, right? 1 by 3 not same. If not same means this one cannot multiply. You don't need to copy the question anymore because you don't need to multiply at all. Okay, so this one no solution. No solution. Okay, because it's undefined. Right, so that is not possible for you to multiply. The one that is possible is only A, B, and C. Let's look back at the example just now, the first one, okay? So we have this word problem just now, right? Okay, you look at this total price, total mass, okay? How do we actually get this answer, right? Okay, this one is your first row and first column, Okay, this is your first row. We are talking about this first one first. This is first row, first column. So this first row, first column comes from this one and this. First row when we times and plus with the first column. Okay, that's why it's 5 times 1 plus 4 times 2 plus 6 times 3, and the total price is $31. This one comes from these two, which is donut, choco bun, croissant, and from bakery A times with the price. Okay, first row and the first column. Okay, and then the second one, this one, 19. Oops. This 19 comes from second row and your first column. Okay, because the position of this element is second row and first column. So it comes from second row, first column. Alright, means that you multiply 7 times 1 plus 3 times 2 plus 3 times 2, which is the total price of the 3 items in bakery B. Okay, remember this one bakery B, right? This one is the price. Okay, and then as for this 1100, right, is the total mass of bakery A. It comes from this position is first row, second column. First row and second column. Okay, so you multiply and plus and you'll get 1100. Okay, and the last one is your total mass of bakery B, 960, comes from second row and second column. So this is second row and your second column. Okay, and multiply and plus to get this total mass for the bakery B. Okay, so that is how it works for matrices. Your homework for today is exercise 6.3, number 1 until H. Okay, you practice on your matrix multiplication. Okay, and this question, not all can be multiplied. Okay, use the method that I teach you to find out whether this matrix can be multiplied or not, and if can, find out the value and find the matrix of the answer, the product. Alright, so you focus on how to multiply matrices for today. Okay, and please hand in to me for this exercise 6.3, number 1, A until H, and complete all your examples and try it there and upload in your assignment post. Alright, okay, that's all from me today. Bye guys.